Hi, welcome back to Moose and Chemistry. This is electron configuration of platinum PT lesson. Okay, platinum happens to be element number 78 on the periodic table. So write a 78 there, and our atomic mass unit is 195. Since the atomic number is 78, the number of protons is 78. Since it's electrically neutral, it also has to have 78 electrons. And do the neutrons, you do the AMU minus the protons, so that's 195 minus 78, which would give me 117 neutrons. Okay, remember that S holds 2 electrons, P holds 6 electrons, D holds 10 electrons, and F can hold 14 electrons. We're going to use the off-ball principle, which says you have to fill the lower shell first before you fill the upper shell. And we're going to use the diagonal rule to demonstrate the off-ball principle. So we're going to put an X right here. We're going to follow these orange kind of arrows down until we run out of electrons, which are 78 electrons. Okay, so once we use up 78 electrons, we're finished. Okay, let's go ahead and do that. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6. All right, now here comes the fun part. You're going to take 1 away from 6s, and we're going to give it to the 5d. So it's going to be 6s1, 4f14, 5d9. Now we do that because it's an exception. I'm just letting you know there's an exception in elements, and this is just one of the exceptions. Okay, Hund's rule, orbital notation, up and down arrows, of course. And here we go again. And we're going to do that until we run out of electrons. Remember, the up arrows are clockwise, and the down arrows are counterclockwise electrons. Okay, here we go. Just filling her in. Just having a ball. Yeah. But use the habit I'm doing. It may look stupid, but you know what? It's okay. Someone might think you're smart. You know, well, you probably are anyway, but you know, this is a good way to say, hey, look, I know my stuff. Alright, enough silliness. Okay, we're getting down towards the end here. We're just working this through here and getting closer to being finished. Okay. Oh, we're not going to have 6s2, we're going to have 6s1, that's right. So remove this arrow. And then we're going to go ahead and fill these in. And then, of course, 5d9. For 1 second there, I kind of weirded out there. 1, 2, 3, 4, 5, 6, 7, 8. I need one more down arrow. 9. There we go. Noble gas notation. This time, let's get it right. It's going to be Xe. So that's going to be 5p6. Right? So we're going to write Xe first. And then it's going to be 4f14, 5d19, and then of course 6s1. Okay, the quantum numbers, which states that no two elements can have the same set of quantum numbers. But this is really it's kind of weird. All right, because it's in the D block, so it's period 6, but it's in -1, so that's going to be 6 minus 1. It's going to give me 5. So our n value is 5. Our number 2 number, our angular momentum number, is D block. So put a 2 there. And now the magnetic number would normally be 0, but in this case it's going to be 1. It's a special case. And then, of course, the last arrow is not going up, it's going down. So that would be 1/2 negative. Alright, you guys be awesome. And we'll see you back here at Musin Chemistry.